talk about how to find the surface area and the volume of two figures in particular. We're going to focus on prisms, which is just kind of a fancy word for box, okay, and cylinders. And so we'll go through what the formulas for those things are. You do not have to memorize the formulas, okay? So those will be given to you on test or on the TSI or anything that I give you. But you do need to know how to use them and where to find all the different pieces of the formula to plug them into. And so let's talk about these different figures. And we're really going to be focusing mostly on the cylinder and the rectangular prism, although the formulas for cube and the right triangular prism are very similar. And so I do want to talk about, in general, how do we find these just sort of conceptually? What does a surface area and volume mean? But then we'll just kind of go through a bunch of practice problems, and I think you'll find that as long as you can put the correct pieces into the formula in the correct place, you can get these answers pretty easy. This is not going to be as challenging as the transformation stuff that we did last time. So surface area is basically how much space is taken up on the surface of the object. Like if you were going to wrap a present, how much wrapping paper would you need to cover every surface? So in general, to find the total surface area, you want to be thinking about finding the area of each side and then adding them all up. Okay, so for instance, if you look at the rectangular prism formula here, and I wouldn't even really write it like that. I'll kind of show you an easier way to do it. But each one of these W times H, that's the width times the height, the length times the width, the length times the height, those all represent the area of one of the different sides of that figure. So W times H, width times height, would be the side length, the area of this side right here, and a little rectangular side. The length times width, and pick a different color here, represents the area of this rectangle, right? It's length times width. And then length times height, which is that last one, is going to be the area of this front side. So basically you find the area of each side, and then you're going to add them together. Now also notice we got a times 2 on there, and that's because each one of these sides, there's two of them, right? There's the top and the bottom have the same area. The side over here and the side that's parallel to it, they all have the same side, right? There's a total of 6 sides on this figure. So we're just going to double whatever we get there. Okay, so don't worry about memorizing the formula. I'll give it to you, but just conceptually, what you're doing is you're just finding the area of each side, adding them up. Now with the cylinder, the surface area, there's a little bit more going on there, 2 pi r squared plus 2 pi r h. But I kind of want to break down exactly where that formula is coming from, because I think if you understand it conceptually, then you almost memorize it on the spot if you know your circle formulas. So let's say you had let me just grab a piece of paper here, here. And let's say I roll it up, okay? So I roll it up like this. Yeah, and we got a little tube here. Looks like a toilet paper roll or something like that, right? So this is an example of a cylinder, more or less, right? If we want the total surface area of the cylinder, we need to find the area of both of these circular bases, right? The area for a circle is pi r squared. So this 2 pi r squared is talking about the area of the two bases. There's 2 of them. Right? The pi r squared, I should highlight that instead of trying to box it. So the pi r squared is the area of that circle. And then there's 2 of them, right? There's the top and the bottom. Why is it not erasing? Now the 2 pi r h, I think, is not quite as obvious where that comes from, but I'm going to try to show you with this piece of paper I have rolled up here. If I want to find the area going around, in other words, like if you put a label on a can, like a can of beans or something, okay, and you unfold that label, right? That's kind of what this is, right? If I unfold this, I have a rectangle. And we know how to find the area of a rectangle. It's just base times height or length times width. But we want to think about like, well, what exactly is the base and the height in this case? So like if I roll it back up, we can see that like the height is just the height of the cylinder itself, right? That's the h. Right, the h is right here. The 2 pi r is the circumference of this circle, which is the length of this rectangle. Right? This length right here is a circle. Yeah? So like if I were to sort of unwrap this cylinder, I would have the 2 circles, and then I'd have a rectangle, which is the height times 2 pi r. So the area is a rectangle. Right? Just like this. Here's the rectangle. I roll it up. Here's the cylinder. So if I want the surface area, I can think about it as like an unwrapped cylinder. And now it's just a rectangle. And so it's just base times height. So anyway, that's where that formula is coming from. I just want to kind of show you that, you know, it's not just made up and coming out of nowhere. It's really just you're adding together the area of 2 circles and 1 rectangle. Now, as far as the volume is concerned, volume is the amount of space that the object takes up. You can think about it as like, how much water can I pour in here? Yeah, like how much actual 3-dimensional space is it taking up? And for both the rectangular prism and the cylinder, it's the same basic formula, which is the area of the base times the height. So for a cylinder, the area of a base is the pi r squared because the base is a circle, and you multiply that by the height. For the rectangular prism, the base is a rectangle, the length times width, and you multiply that by the height. So in both cases, it's whatever the base area is times the height. Any questions so far? All right, so just to kind of sum up here, volume represents how much space is inside the object. Surface area represents how much space is on the outside of the object. Like if you were to wrap a present, how much wrapping paper would you need? Versus you have a box, how much stuff can fit inside? All right, so from here on out, we're just going to be looking at different examples of prisms and cylinders and finding the volume and surface area. We'll start with volume because I think volume is a little easier. So for the volume here, we're just going to find the area of the base times the height. So the base here is a rectangle. It's the same rectangle as we see up above, and it looks like it's just a 1 by 1 here. All right, so here's the area of the base. Right, and from the diagram, how it's diagrammed up there, it's like a 1 by 1. And so we're going to multiply whatever that area is by the height. Okay, so the area is the length times the width times the height for our prism. So this one's usually the easiest one to get because you just multiply the 3 dimensions together. So the area of the base would be 1 times 1, and then times the height, so times 3. So almost don't even need a calculator for this, right? 1 times 1 times 3 is just 3. Now, when we're talking, when we want to answer these questions about volume and surface area, it's also important that we understand what kind of units we're dealing with. A volume unit is going to be some sort of cubic distance. Okay, there's 3 dimensions. So in this case, the volume is 3 cubic feet. Now, when you're talking about surface area, that unit is going to be a squared distance because it's an area. It's like a flat plane rather than a 3-dimensional figure. Okay, well, let's kind of move on here. So the second one, the volume is going to, again, be the base area times the height. Base area, once again, is this rectangle down here, which is 1 by 1, and the height is 3. This is the same one, isn't it? Why does it look different? This is just a 1 by 1 by 3. So yeah, this is also going to be 3 cubic feet. That one's kind of boring. We just did one. I don't know why it looks like that. All right, so for these ones down here, same process. We've got the base area times the height. So for this, for number 3, here's the base. I'm trying my best to kind of shade it in here. All right, and you can see that the base is 3 by 8. So the area is the length times the width times the height. So 3 times 8 times the height is 2. Yes, sir. Of course. Now, if the numbers start getting a little big, I mean, you might be able to still do this without a calculator, but once they start getting a little bigger, don't be afraid to use the calculator here. 3 times 8 is 24, times 2 is 48. So the volume is 48 cubic meters. This last one has a base area of whatever 10 by 10 is. So length times width times height will be 10 times 10. Well, this one's actually a cube. That's okay. We can just treat it the same way. I'm just going to multiply each of the dimensions together. 10 times 10 times 10. It's going to be a 1 with 3 zeros. So it's 1,000 cubic centimeters. So yeah, volume is always going to have that cubic unit. Any questions so far? And when we find the volume of a cylinder, we're going to do pretty much the exact same thing, but the area of the base is different. Yes, ma'am?
The answers for the volume?
Yeah.
So for volume, is it always to the power of 3?
Yes, the units will always be cubic units because they're 3-dimensional. Okay. Now, surface area, anytime you find an area, that's going to have a squared unit because it's 2-dimensional, just length and width. There's no depth to it. So yeah, and this is kind of like when you write the units, if it's just a distance, like from here to there, let's say it's like 10 meters. It's just meters. If I talk about an area that's 2-dimensional, like a plane, that would be meters squared. And then if it's 3-dimensional, it'd be meters cubed. And then if you want to kind of break your brain a little bit and start to think about what a 4-dimensional object might look like, that would be meters to the 4th power. But we're not going to go there. Yeah. But maybe good for a thought experiment, what a 4-dimensional cube might look like. Yeah, our brains are not really equipped to handle that. Yeah. All right, anyway. We're going to keep moving on here. So we're talking about cylinders. And we're going to approach this volume the same way, where it's the base area times the height. But the big difference here is that the base is no longer a rectangle, it is a circle. So to find the area of a circle, you do pi r squared. And then multiply it by the height, just like we did with the rectangular prism. So in this case, the radius is 4, the height is 6. So this is going to be pi times 4 squared times 6. Now, because of that pi that's in there, that's an irrational number. You can't really write it as a decimal. I mean, you could estimate it and say it's 3.14, but since you have calculators, you can just use the pi button. But what's going to end up happening is, for all of these problems that involve pi, you're going to get this long decimal. So we're just going to round to maybe 1 or 2 decimal places here. So we'll just type that in. Pi times 4 squared times 6. And I'm getting approximately So I'm going to use this approximate symbol, 301, and let's just round to 2 decimal places here, 59. So 301.59, this is going to be cubic inches. And just to clarify, kind of coming back to your question, the cube is only on the units. You're not going to cube the actual number, just on the unit. So let's do another one. We have the base area times the height.
Okay, so we just had some technical difficulties, and for whatever reason, the audio of the video totally cut out at this point. So I'm just going to try to narrate what I'm writing down. It might be kind of weird because I'm just kind of looking at what I have versus like solving it and teaching live. So just bear with me. On number 6, we're trying to find the volume of the cylinder, where we need to find the base area and multiply that by the height like we did in the previous problems. So in this problem, the radius is 2 and the height is 6. So we need pi times 2 squared times 6, which you can put in your calculator and get 75.4 cubic centimeters. All of these cylinder volume problems are going to be worked basically the same way. If you're given the radius and the height, then you just need to plug them into that formula. So let's do a few more examples here. At number 7, we've got a radius of 5 and a height of 17. So we're going to calculate the volume the same way we did the other ones. We're going to find the base area and then multiply that by the height. So the base is a circle, and so that base area will be pi r squared. So we're doing pi r squared times the height. Since the radius is 5 and the height is 17, we can substitute those numbers into r and to h, respectively. This is something that you're going to put into the calculator, especially if you need to get a rounded answer. Now, even if this were if I wanted an answer that was in terms of pi, I'd probably just have you use the calculator to do the 17 times 25 anyway. But yeah, so you're going to use a calculator, and you should get 1,335.18 cubic feet. You always want to take a look at what the units are to make sure that we are writing the correct thing. So yeah, we've got another cylinder here, trying to find the volume, which means we need to find the base area and multiply it by the height, just like all of these prisms and cylinders. So the base, again, is a circle. So the area of that is pi r squared. We're going to multiply that by the height. We can see that the radius is 8 and the height is 22. So we just need to put all that into the calculator once again. Pi times 8 squared times 22. And yeah, let's just kind of wait for the answer to come up because I don't have a calculator with me, unfortunately. So what did we get? Let's see. Taking our time here. Oh, there we go. Looks like we got 4,423.36. Since the height and the radius are given in millimeters, our volume should be in cubic millimeters. So if I recall, this was the last volume problem that we went over, and then we started looking at some surface area problems. But let's see. Yep, okay, I was right. So we'll start off by finding the surface area of a rectangular prism, and we'll do a few problems like that. And then we will start looking at the surface area of a cylinder. So when we find the surface area of a rectangle, the strategy here is going to be to actually just find the area of each side, and then we'll add those up. So a rectangular prism has 6 sides, but 3 of them are going to have the same area as the one that's across from them. So like if you see, look at the side that I'm highlighting now, like the sort of the bottom of the rectangular prism, it has the same area as what's on top. They're the same shape, which is in this case a 1 by 1 square. And so we only need to find the area of one of those, and then we can double it. But that's going to be true for all the sort of pairs of sides. Like the purple one that I'm highlighting now has the same area as that other side, like kind of to the left there. So looks like I'm struggling to highlight it. Bear with me here. Yeah, so anyway, those two sides have the same area. So again, you only really need to find the area of one of them and then double it. And the same thing is going to be true for like the front and the back. So like the two sides that I haven't really highlighted here, can't really recall if I highlighted them in class, but those two sides should have the same area as well. So the overall strategy here is going to be to find the area of the three unique sides and then double all of them. So yeah, that's how we're going to find the surface here. We're going to duplicate all three of those sides. So the red one, or I guess it's more pink, is a 1 by 1. The purple side is a 3 by 1. And so is the one that's not shaded, that sort of front and back side. So we'll find the area of those three rectangles. The 1 times 1 is 1, 3 times 1 is 3, and so forth. And now we just got to crank through the arithmetic here. So we got 7 times 2, which is 14. Now we're working with surface area. Our units, just like with any area, should be squared, not cubed and not linear. So yeah, we're going to have square feet rather than, like we had in volume, cubic feet. And that's just because an area is 2-dimensional versus volume, which is 3-dimensional. Okay, so number 2, looks like that has the same dimensions as the first one, so looks like we just kind of skipped that one and wrote the answer in. Didn't spend any time kind of reworking that. So let's look at number 3 that has a different set of dimensions. This one is a 3 by 8 by 2 rectangular prism. So there's going to be, once again, a set of 3 unique sides. And they may not be unique. You might have 2 sides that are the same, but 3 kind of sides that we're looking at to double up on. So like what I'm highlighting there, those 2 sides have the same area. So we're just going to count it once and then double them all at the end. So yeah, we've got those 2 sides that are same. We've got the 8 by 2 rectangle that is sort of on the right that is going to be the same as the one that would be like on the left side. It looks like I stopped highlighting it, so I guess we're just going to, oh, nope, there I go. Okay, I'm highlighting it in green, and hopefully I highlight the other rectangle that has the same area so you can kind of see it. I'm pretty sure I did. Maybe I didn't. Okay, I don't know. So anyway, that first side that we're doubling is 3 by 2, and then the green one that you're looking at is 8 by 2, and then the one on top that I'm highlighting there is going to be 8 by 3. And so you basically have those 3 unique sides. We'll add those up, and then since each side has a corresponding side, like on the other, I just feel like I said side too many times here, but on the other side of the box, or the rectangular prism, we're going to double each one of those. So we've got 3 times 2, which should be 6, 8 times 2, which will be 16, and 3 times 8, which is 24. I'm not sure what the delay is here. I'm probably just going through some explanation in class, but there we go. 6 plus 16 plus 24, all that times 2. So we got 46 times 2, which would be what, 92, I think? Yeah, so that one works out. Didn't really need a calculator for that one. So 92, and since all the side lengths are given in meters, it should be meters squared. Now, number 4 is a rectangular prism, but you might also notice that all of the side lengths are the same. So this would actually be a cube. And so there's 2 ways you could think about this. You could work it out the same way we did the last 2 problems, but it is not going to take long for you to realize that all of the sides are the same. So instead of finding like a 10 by 10, and then another 10 by 10, and another 10 by 10, like I'm writing here, you could also write it, since all 6 sides are the same, as 6 times 10 by 10. In other words, find the area of just one of those 6 sides, and then instead of just duplicating it, multiplying it by 6. And so, yeah, here's what I'm writing there, 6 times 10 times 10. In other words, we've got one side, which is 10 by 10, or 100, and then just multiply that by 6. Now, it doesn't really matter what one of these 2 ways you decide to work the problem. You should get 600 square centimeters either way. Yeah, and it looks like I'm just doing a little more explanation here. I don't really remember what I was saying to elaborate on that. There's really not much else to say. Maybe I'm just really trying to emphasize that you can work that out either way. Okay, now we're going to look at some cylinders. So this one, these are going to really require a little bit more of an explanation, I think, as far as where the formula is coming from. With the rectangular prism, it's pretty obvious because all the sides are just clearly rectangles, so it's just base times height for each side. But for a cylinder, the formula is 2 pi r squared plus 2 pi r times the height. And so I'm going to do my best to explain this to you. In class, I was doing a lot of like physical explanation. And so this is what I want you to kind of imagine if you're watching this video after the fact, is that imagine you have like a piece of paper that you've rolled up into what looks like a cylinder, or like, here's another way of thinking about it. Imagine you have like a toilet paper roll, right? That's a cylinder. And let's say you cut the toilet paper roll just like straight down so that you can sort of unravel it. And if you were to do that and kind of pull it apart, you would get a rectangle. Just like if you were to take a piece of paper, which is a rectangle, and roll it up so that it looks like a cylinder. Gosh, I really wish I could show you a visual here. I might throw in something after the fact here to really explain this. But if you were to unravel that toilet paper roll or that piece of paper, you have a rectangle. So ultimately, the area of the side kind of going around the cylinder is a rectangle, where the height is the 6 inches here, but the length is the circumference of the circle. So in this case, so that's where this formula is coming from. Okay, you've basically got two bases that are both circles. The area of each base is pi r squared. So that's where the 2 pi r squared is coming from. And then the 2 pi r h is really just the area of the space going around the cylinder. Like imagine you had like a can of beans and you take off the label. The area of that label is that 2 pi r h, which is the circumference of the circle times the height. So anyway, once you get that formula set up, and just as a reminder, you do not have to memorize that formula. You'll get the formula. So as long as you can correctly identify the radius and the height, you really shouldn't have too much of a problem with this because you're using a calculator. But the radius here is 4. The height is 6. And so if you throw all that in your calculator, you get 251.33 square inches. So, but yeah, I do recall going into some detail during class where I really tried to show you where that formula is coming from, so you could conceptually understand, that this isn't just some random formula. But at the end of the day, you don't have to memorize it anyway, so don't worry too much if this explanation is not really doing the job of helping you understand where that's coming from. So, okay, with this second one, it's got a radius of 2 and a height of 6. So we're just going to substitute in 2 for r and 6 for h, throw everything into the calculator, and this one ends up having a surface area of 100.53 square centimeters. Oh, nope, I wrote inches. Okay, good thing I caught that. Yep, square centimeters. So that leaves us with just 2 problems left here, number 7 and 8, which we'll solve similarly. Again, once you figure out that you just need to plug in the r and the h and then put everything in your calculator, this is definitely going to be some easier problems compared to what we did with the transformations. Okay, so this number 7 has got a radius of 5 and a height of 17. So we are going to substitute in 5 for r and 17 for h. So let's see, make sure I didn't make any mistakes here. Let's see what's going on. 2 pi times 5 squared. Yep, okay, good. And then we're plugging in the 5 for r, 17 for h. Everything looks good here. At this point, just hope that you can type it in the calculator correctly, because that's really the only place you could go wrong here. What answer did we get? Maybe like, what is that? 50 pi plus 17 times 5. That's too much. Let's see what we got. 691.15, and that should be square feet. So make sure I write that correctly. Everything looks good. Okay, that leaves us with one last problem on today's notes. Number 8, we're going to use the same formula, that 2 pi r squared plus 2 pi r h. In this case, the radius is 8 millimeters, and the height is 22 millimeters. So we'll substitute in 8 for the radius, 22 for the height, and then throw all that into the calculator. And here we go. We're just setting up the formula, making sure that we plug in everything into the right place. So we got 8 going into the R and 22 going into H. I'm going to plug all that into the calculator. And yeah, who knows what that's going to be? Let's find out. All right, we got 1,507.96 square millimeters. And that's going to about do it for tonight's notes. Sorry for the technical difficulties. I'm sure my explanation was probably way better in class than now. Just really want to, with that surface area formula for the cylinder, it's hard for me to talk through it, but with a visual, I really think it makes a lot of sense once you kind of see where the different pieces are coming from. Again, it's just the 2 base circles. That's the 2 pi r squared part. And then that 2 pi r h is really just like a rectangle formula in disguise, where it's like base times the height. It's just that the base, or like the length of that rectangle, is the circumference of the circle. So that's why it's 2 pi r. Anyway, that's it for today. Thanks for watching. Y'all have a great day. I'll see you next time.